Part B on the question says the mean weight of 500 packaging tins from a production process are normally distributed with a mean weight of 155 grams and standard deviations of 15 grams. Required, the number of packaging tins that weigh between 120 grams and 155 grams. Number two, the number of packaging tins that weigh more than 185 grams. 185 grams. So that question, has come from the topic of probability theory. Dennis, welcome back. We're now in question 2B. So the question has come from probability theory. Probability theory. And specifically normal distribution. Normal distribution. Normal distribution. That's where it has come from. Now we are told to get the number of tins that are between 120 and 155. So between 120 grams and 155 grams. 155 grams. So when I told you this one, you begin by drawing the table like this. Begin by drawing the table. So here you put the mean. The mean we are told is 151. And then we are looking for x1 here, which is 120. And then x2 here, which is 155. And the standard deviation is 15. The standard deviation is 15. Then you should shade the area of interest. You should shade the area of interest. Area of interest. Area of interest. So we are going then to have Z1 as x1 minus x bar. You divide by standard deviation. So this will be 120 minus 151, which is divided by 15 to be equal to negative 2.07, negative 2.07. Then we come and compute Z2 as x2 minus x bar. You divide by standard deviation. So this is 155 minus 151. You divide by 15. Divide by 15. 0.27. 0.27. Then from there you see from the tables, probability that we are between 120 and 155. I have got the tables and read for me this one 2.0. Zero 0.48. Sasa hiyo ni ya from here 151 here. Tusome hii nyingine ndio tuseme plus. Zero point 1.64. So when we add that, if you add those, this becomes 0.72. Good. So the teens will then be 0.5872 times 500. Those are the number of teens times 500. 293. So 293 teens. 293. Okay. Then from there, we are told to look for the ones that are more than 185 grams. More than 185 grams. So again, we seek to draw a table. We seek to draw a table here, whereby here we have the mean. X bar is 151. Standard deviation is 15. And then here, X1 is 185. Namna hiyo. 185 that way. So now get Z1 as X1 minus X bar. We divide by standard deviation. So this is 185 minus 151. You divide by 15. And then look up here from the tables. probability that x is greater than or equal to 185, it will be what? And then you give me the number of teams. Then you give me the number of teams. So how many teams? Umepata? 5 teams. Okay. What's up? Okay. So we have gotten 5 teams. Because here the same is 0.5 minus 0.48. Another 8. 8, 4. The answer was 0.0116. So 0.0116 times 500 is the one you're saying is giving us 5 teams. Okay, good. 5 teams. So Grace, karibu. So we are now in question 2, part C. Question 2, part C, where we are told the following data were obtained from the records of Kiwandani Limited for the year 2015. So we are required to get the least squares regression function and the coefficient of determination. So again, we need to know that has been extracted from where. I told you these questions. So the question has come from regression and correlation theory. Regression and correlation theory. That is the topic where it has been extracted from. Regression and correlation theory. Now from there, specifically we are told to bring least squares equation, least squares function or equation, least squares function. Now this, you start by saying format. Format is y is equals to a plus bx. That is the format of a least squares function, where you proceed again and inform us that b is m sum of xy minus sum of x sum of y sum of x minus, you divide this by n sum of x squared minus sum of x, you square that, and then a is sum of y minus b sum of x, you divide by n, divide by n. The second thing that we are told to compute is called coefficients of determination. Coefficient of determination. And this coefficient of determination, r squared between x and y, is given as n sum of xy minus sum of x sum of y. You divide by n sum of x squared minus sum of x square, hiyo unaweka kwa brackets, then unasema times n sum of y squared minus sum of y square. Then the whole of this you will square. The whole of this you will square. Some people will even say you multiply by 100, so you can even multiply by 100. Or you can leave it with a decimal. So that is the first step. When you're dealing with these questions, that is the first step of getting to write the formulas. Getting to write the formulas. Okay. Then from there, we seek to prepare the analysis table. And I believe we all know how to use the calculus. Okay? So unakumbuka kutumia calculator for regression. Chachini, unakumbuka eh? Haya. So what we will do, but kama hukuki unatengeneza ile table ya kawaida. So what we will do, tutakuja hapa now down there you say using calculator. Using calculator. Let's set the calc for regression. We say you press mode. Mpaka uone REG. You press the number below REG so that you see LIN. You press the number below it. We are there. And then we say you must always start by keying in the values of X. Yeah. And in many questions, the values of X are given at the first column. But unaona kwa hii wamepeana as a second column. Yeah. So let's start keying in. So weka 1056, comma, 16250, 16250 M plus. Hiyo ingine weka 736, comma, 15,000 M plus. Hiyo ingine weka 840, comma, 15,000 M plus. The next one 800, comma, 14,500 M plus. The next one is 880, comma, 15,250 M plus. The last one is 1008, comma, 15,750 M plus. Now you have n is equal to what? 6. So we can even start that way. N is equal to 6. Using calculator, you can see that n is equal to 6. N is equal to 6. Okay, so now press shift button number 1. The first item you see is sum of x square. I press the number below it and then you press equals. And tell me whether you are able to get 47928, 47928, 96. Is that what you have? Okay. It will be a tenor. Shift button number 1. The second item you see is sum of x. So you write sum of x is equals to. So press the number below it and then press equals. You get 5,320. Okay. Turudia tena. Shift button number 1. Now replay forward once. Replay forward once. The next item you see is sum of y squared. So sum of y squared is check whether you have 140, 493, 7500. You have such. I have to get tena shift. Button number 1. We pray forward once. The second item you see is sum of y. So sum of y. I press the number below it and press equals. Tell me whether you get 91, 7, 50. So then repeat the same. Shift button number 1. We pray forward. Now you see sum of xy. Sum of xy. Press the number below it and press equals and tell me whether you get 8169 6000. You have that. Actually, you don't even have to use the calc because you know what you're looking for according to this. Unaziweka tu kwa calculator straight. X square, like now kama hii ya kwanza, 1056 square plus 736 square, kawaida tu, and then you write the total. So, okay. Then now after the second step, where we get the data. The third step is substitution. Substitution. Now, in the substitution, we start with B. According to our formula, B requires n, and we know n is 6 times sum of xy, which we already have. 816,9600 minus sum of x, 5320 times sum of y, 91750. You divide by 6 times sum of x squared, 4792896 minus 5320 times 5320 times 5320. Now that one, you don't substitute, you don't solve, you still get the answer from the calc, whereby you say shift, button number 2, you go all the way to where we pray forward up to where you get B, you press the number below it, and that gives us what? 4.54. Now, akikuuliza hiyo ni nini, you can tell them this is cost per hour. This is cost per hour. The variable provides per hour. It is the cost per hour. We are told to interpret, although this one is not required. Then we got A. So A, we are going to have a sum of y. Sum of y is 91750 minus 4.54 times sum of x, which is 5320. You divide it by 6. Divide it by 6. And when you do that, you press shift button number 2. You pray forward. Mpaka mahali utapata A, press 1, you press equals. What do you get? 11,265. Point 4. Now this is the fixed cost. If you want to be young, that represents the fixed cost. Thus, y will be equal to 11,265.4 plus 4.54x. 4.54x. So now, R square between x and y, R square between x and y, we now substitute so that we have 6 times 816,96,000 minus 5320 times 91,750. So this one, you divide by the square root of, divide by the square root of 6 times 479,2896 minus 5320 squared. Then times 6 multiplied by sum of y squared. Y squared is 140, 493, 7500 minus sum of y, that is 91,750 squared. Now the whole of this, we will square the whole of that, we will square. So we shall substitute those values again. You have to answer for a calculator, where you say shift button number 2. You will pray forward until where you see R, and you get, now that value that you get squared, now square kawaida, get the square of that value so that you record 0.81, which is the same thing as 81%. You get 0.81, which is 81%. So the meaning of that, or the interpretation of that, this shows that 81% of overhead costs, 81% of overhead costs in the above case, is explained by direct labor hours. Is explained by direct labor hours. When we say explained, we simply mean it is brought about by, or it is caused by. Caused by. So I think that is good. We are comfortable with that. We seek to proceed now to question number 3. Question number 3 now. Question number 3. A, we are told explain the following terms as used in game theory. Explain the following terms as they used in game theory. So that question is coming from games theory. Games theory, and specifically terms or definitions. Coming from terms or definitions. Terms. So the first one we are told to explain about payoff. So that can be a payoff is the outcome of a game. A payoff is the outcome of a game that depends on the strategies selected by the competitors. That depends on the strategies selected by competitors. Selected by competitors. Okay, number 2, the value of a game. Value of a game refers to the expected payoff. Refers to the expected payoff obtained by a competitor. After using the optimal strategies. Obtained by a competitor after using the optimal strategy. Optimal strategy. Optimal strategy. So I think that is clear. Those are the 2 terms as required in the games. But B, highlight 8 steps followed in the simulation process. So that now imetolewa kwa topic inaitwa simulation, and specifically tunaulizwa steps. Specifically steps. Now, the way we have been handling simulation, we have not been following or mentioning these steps, but they are the ones that we have been using. And again, the way we have been doing it in class, these steps may not come out expressive or very clear compared with when you are doing it out there as a full project. And also the other reason why here they don't come out clearly is because simulation is supposed to be done using computers. we are supposed to be in a computer lab, kila mtu akiwa na computer yake, that's what we're supposed to do simulation well. So in the absence of computers, some of the steps that we have here may not come out clear. So number one is called problem definition as the first step. Problem definition. Number two, inaitwa project planning. Project planning. Project planning. Project planning. That's the second step. Number three, inaitwa system definition. System definition. Step number four, inaitwa model formulation. Model formulation. Number five, inaitwa input data collection and analysis. Input data collection and analysis. Another one inaitwa model translation. Model translation. Model translation. Number seven inaitwa verification and validation. Verification and validation. Verification and validation. The last one inaitwa experimentation and analysis. Experimentation and analysis. So basically, what we have been doing is all this, or is some of this. Number one, when we say problem definition, it is where we have been talking of identifying the objective. What is it that you are asked? We have come across some questions that have been asking us to compute the profit. So we must start by knowing what? Profit. Then step number two, what they are calling the project planning. It is where now you have an overview of the question. You are able to know what is it that is required, what has been provided. Then number three, we are calling it system definition. Now system definition is where you come up with some formulas that will connect the various items. Then number four is what you're calling model formulation. Model formulation ni sasa kuchora ile sheet. Kumbuka ile sheet tunachora ile inaenda mpaka huko kwa profit ama kwa calculation. Then from there we have the input data collection and analysis. Now at that point we pale tunaweka random numbers, unakimbia kwa Monte Carlo. Unajua hiyo ni how many or how much depending on what you're dealing with. Then model translation is where now you use those values. Ukiangalia kama one of the sheets tumekuwa nazo, tunakuanga na formula huko tunasema maybe A times B minus B, something like that. So that is model translation. Then from there, once you have the answers here, the last column, you can verify. Although ourselves we have not been verified, we have been hoping that what we have done initially has been correct. But if you doubt, then you cross-check. That's what we call verification and validation. We're using the computer. There are ways in which the software will help validate the data. If there is an error, it will alert you. And then finally, you experiment. So I'm saying the next question is about the Spearman. And this one, it is also coming from the topic we have called the regression. The regression and correlation theory. That's where it's coming from, and specifically it's coming from Spearman. So Spearman. Regression and correlation theory. And when you look at it, we have column number 1, where we have sales agent, sales agent, sales agent. Then for this one, we have actual sales, actual sales. Actual sales, we have amount, and then we have rank, we have amount, rank. We come and do the same thing, target sales, where we also have amount, then we have rank. Then we get difference squared. Difference squared. Difference squared. So you now copy the data as provided. We have 1, 2, 3, 4, 5, 6, 7, 8. Then the last column. Five, 40, 41 and 27, 50 and 45, 56 and 38, 60 and 52, 42 and 35, 43 and 29, and 52 and 44. So we can start ranking. Okay. So hapa number 1 ni Rivers here, followed by 56, followed by 52, followed by 50, followed by 45, followed by 43. This is number 7 and this is number 8. Kuja huku kwa target, number 1 ni huyu wa 52, akifuatwa na 45 as number 2, akifuatwa na 44 number 3, akifuatwa na 40 number 4, ikifuatwa na 38 number 5, followed by 35 as 6. Followed by this one as 7 and this one as 8. Then to get the difference squared is 5 minus 1 square is 1. 8 minus 8 square is 0. 4 minus 2 square is 4. 2 minus 5 square is 9. 1 minus 1 square is 0. 7 minus 6 square is 1. 6 minus 7 square is 1. 3 minus 3 square is 0. So if you add this is 5, that is 14, 16. So we have a total of 16. So the next thing now to appear the formula, it is RS is equals to 1 minus 6 sum over b squared divided by n into brackets n square minus 1, n square minus 1. So this is 1 minus 6 times 16. You divide by 8 into brackets 8 squared minus 1. And this becomes 1 minus. Give me 2 decimals. Zero 0.1905. So finally, that is 0. 8095. 8095. So the interpretation of that is that this shows a very strong relationship between target and actual sales. This is 16 is already squared. So in that way, it's already squared. That's why it's called difference squared. Okay. The interpretation is, you see now this is close to 1, the closer to 1, the stronger the relationship. So sasa hiyo itasema this shows a very strong relationship. A very strong relationship between target and actual sales in the above case. This shows a very strong relationship between target and actual sales in the above case. Target and actual sales above the far away is from 1 or closer to 0. The closer it is to 0. Actually, the range of the interpretation is between 0 and 1. So the closer you are to 0, the weaker. The closer you are to 1, the stronger. If it is exactly 0, it means no relationship at all. And if it is exactly equal to 1, it means a perfect relationship. Perfect relationship. Perfect means if this one changes 100%, the other one must change also 100%. But 0 kumaanisha if this one changes, you will not see a change in the other. Like now you are coming to this class as classmates, the relationship is 0. You did not come because your friend came. You did not first of all call them and let's now go to class. But kama kwanza mnapigiana simu mnasema leo tunaenda. Na for sure mnakuja. Ama mnasema leo hatuendi and for sure hamkuji. So we proceed to part B. A cashier at a departmental store can serve on average 24 customers per hour. The arrival rate of customers averages 20 customers per hour. The departmental store applies a single channel queuing system. Required, the probability that the cashier is idle. So that question is coming from another area I've been telling you very popular in the examiner called queuing theory. Queuing theory. And I've been telling you, kama hawataleta mahesabu, wataleta a theory. If it's not simple computations, it is theory. Now, I told you, when you are dealing with queuing, myself, there are 3 things that you must be able to pick and pick correctly. One is the number of channels, which is usually represented by letter M. The number of channels. And channels refers to the point at which the customer will be served. So, how many channels or how many counters do we have here? It is 1. We even told this. It is 1. Number 2, you must identify what we call the arrival rate. Arrival rate is represented by RAPGA. That rate, RAPGA. So customers are coming in at the rate of what? 20 per hour. It is 20 per hour. It's 20 per hour. And number 3, you must be able to identify what we call the service rate. And service rate is represented by mu. And this question is very clear that it is 24 per hour. It is 24 per hour. And I told you that these 2 must always be expressed within the same time frame. They must be expressed within the same time frame. So, ukiulizwa the probability that we are idle. So, probability of being idle, probability of being idle, that one is given as P naught is 1 minus lambda minus mu. That's the formula of getting the probability of being idle. So this then will be 1 minus 20 out of 24. 20 out of 24. You have 0.17. Then tunaulizwa number of customers in the system. Number of customers in the system. Number of customers in the system, we say which is represented by LS, which is given as lambda, you divide by mu minus lambda. LS, that's the number of customers. So this then will be 20. You divide by 24 minus 20. 4 minus 20. That is 5. 5 customers. And finally, waiting time in the queue. Waiting time in the queue. Ile unangoja pale kwa queue, unangoja kwa served. This one I told you, we call it WQ, and it's computed as lambda. Mu brackets mu minus lambda. That is how you compute it. So this becomes 20 by 24 brackets 24 minus 20. $0.2083 hours. 0.028 hours. So make sure you go back to your notes and check the other formulas. I think they are around 7. Familiarize yourself with them. That would be good. So we then call it a junction. Thank you so much for attending the lesson.